All right, here we go. We're gonna try this shit again. See if we're able to make some sense out of this. And we have this very interesting function, right? The gamma function. So first of all, I was trying to try that f again, but we have. I guess this is what like the what do you call it? Definitionsmängde. Dude, what does this even mean? It translates to any real number. Is that what like gamma function? Like the inputs could be from 0 and up, and that arrow to that real number set. Um, See, I'm not even sure what that means. What would it mean? Well, whatever. We're gonna figure it out later. But so and it is defined. So this is the function. X is the input, and the integral, and this and that. So t x minus 1 e minus t dt. Cool. And I was gonna now the only thing that I should do is check if it's true for x1, 2, 3, 4, and but the extra credit that is what I think we should go for, because the other thing is kind of like whatever, right? So now let's see. We have it has a remarkable property that we have looked at earlier before or whatever, where any x that is an element of the natural number set would give us that um, the gamma function would give us for any particular input x, we would get x minus 1 factorial. And what is that even? So, oh yes, that gives us the definition for a factorial. For instance, we have that n factorial would be g n plus 1, right? And this makes sense. So, but then now I'm going to compute pi factorial, which earlier, whoopsie daisy, earlier I said that, what did I say? We were going to have, let's see, what were we going to have? Oh, yeah. So, G, G, G unit. And that's going to be pi plus 1. That is going to give me pi factorial. Correct. That's not even a question. That's just, that makes sense. And then we have, so all right, so back to this. So if we input pi plus 1 here, all we're going to get is t pi. And then this, right? Now, this is now just some calculus stuff, right? Isn't it? I mean, we just gotta compute this integral, solve it, define integral. I like bestemt to bestemt. I only know it in Norwegian, but all right, it's cool. And so anyway, how would I do it? How would I do it? Could I? What if I? Oh wait, now it's kind of getting to a stop here. So if I did the variable change, would that even do anything? All right, so we put in minus out in front. We got that. That could be u, but then it would be like kind of the same shit. So no, right? But so and then, well, wait a minute. Let me zoom out a little bit. Let's do the integral here. We got now we got this, right? And that's fine. So u, if we put the minus up front there, we put the minus there, then yeah, all right, cool. So u, it would be minus t. And then so, and then v, no, wait a goddamn minute. If I just, what would be the simplest here? Because then I would have minus 1. Oh, that would not actually make it any simpler, would it? Even if I derivate that one, what would I get? I would just get pi, t pi minus 1. And that would just complicate it further, right? Am I missing something? I should probably get some coffee actually, but doesn't matter. Either way, that EA Sports, it's in the game. That wouldn't change at all, really. I mean, it wouldn't change anything. So, also that you. I think the problem here is that I maybe. Actually, I don't see a way to figure out this integral. Now, how would I do it? How would I do it? To take the integral, do I even. Holy shit. Is there something obvious that I'm missing? This is just calculus that I'm fucking up right now, which I should probably know, but doesn't matter. Let's just fucking try something, I guess. But I'm kind of stumped now. This is the moment where I'm not going to look it up. I'm going to try to peer behind the curtain of what does it really mean. Let's ask some questions. All right. So the integral. I mean, I imagine it as being the area under the between the graph and the x-axis. That's kind of the only thing that pops out right now, but what does that even mean in this case? I'm not sure. We're looking into it. Wow. But then t pi. There's no way of rewriting this, is there? If we have this, no, because this would be actually this whole thing. Now if I derivate it, it would be just, wait, let's say that it would just be pi t and whatever. And let's just call this like that. Okay, just try it. And then this would be t pi plus 1, pi plus 1. Okay, now v would obviously just be this, and then this would just be this. And so what? We got u, we got v, we got the e under there, the t. Now that's what's fucking me up kind of a little bit here, actually. What does t even represent? How can I make a integral as like a function? I've never seen this before. There's something I'm not getting. Maybe I don't quite understand here why. Because I'm thinking like x and t, they have to represent something, right? But what would t actually be? How can I have? Is the integral itself? Is that not also kind of a function? Some things. Is this a function within a function? No, wait. All right, you know what? I think I've done an honest attempt at this. So I'm going to, I guess, look it up. So then, um, yeah. All right, I'm gonna go, get some coffee, and then we're gonna go look it up. And let's get at it. So, um, I'm not a like. Yeah, I got fuck. I'm go fuck. I have to cancel my Chat GPT Plus. I know. I get it. I'm a hypocrite. but sometimes you fuck. I don't know. Not using it as much. Okay. Now I'm trying to rationalize it. This is not what the video is about. I'm gonna figure this out, but right now I'm gonna use it. And so gamma function. Holy shit. Gamma function helps find factorial. I want to check g of x equals integral from 0 to infinity. I hope it understands what I'm trying to do. T raised x minus 1, and then we got e raised minus t dt, and I want to use pi plus 1 as input to get pi factorial. Hope it gets this. All right, so well, at least it's saying something. Now this is pi is not in normal factorial because factorials are originally defined only for non-negative integers. Yes, well, that's kind of we knew that, but this function should allow us to but how do I would I say calculate here? Calculate this integral or solve it. I don't know. So this is why I haven't figured it out, because it's saying that you generally cannot calculate by elementary antiderivatives. Numeral approximation, but area under this function, yes, decays very fast. You can approximate 0 to 30 using numerical methods like Simpson's rule. So what do they want? Do they not want me to compute this by hand? Now this is kind of tricky. Yeah. Yes, it would. Yes. I'm saying I have a problem saying. Fuck. But what am I thinking right now? Well, the first thing, what am I thinking? I need to start meditating more. I'm being cloudy as of late. I sense a disturbance in the force. All right, doesn't matter. So the first thing now is, well, why? Let's ask some questions. Why couldn't I solve it by elementary antiderivatives? What if I use the product rule from derivations and translate it? What would I say? Manipulate it to serve me in solving this. I don't know what the fuck. I don't know what the fuck I'm saying right now. Okay, but strong mathematical reasons to believe one does not exist. Yeah, because it's a product, right? Is it not? Integration by parts. That's what I was trying to get at. Yeah. Oh, right. Yes, that makes sense. Okay. So, right. I could have like peeled it back like an onion. If it was, yes, but it's not going to leave me with just that thing, right? Although, and still, how would it have helped? Actually, no, wait a minute. Yes, it dropped, right? But then I would still have to sum it up. No, I believe it could be done. All right. Well, so hold on, I gotta fucking. All right, cool. And so then, but I have in the book of proof a question that wants me to compute pi factorial using this definition of the gamma function. So what do they expect me to do here? What am I supposed to learn or see? Define, prove, using integration by parts, compute 1, deduce that n plus 1. Then the key step is x plus 1. Yeah, we got it. Wait a minute. Now what is this? X plus 1? That's equal to tx, which is equal. How is that equal to that? X would be a variable. Would this rule apply? I mean, surely it would. Yes. But then, oh, that's kind of neat, I guess. And then this recurrence relation is the analog of yeah, but how does that fit in? There's a lot of thing behind the scenes here that I'm not quite seeing now. All right, so now suppose the exercise asks for pi factorial. The idea is this and then recurrence. So we got, yes, that would be p gamma of pi, which would also be p pi minus. Oh, hello. Yeah. Now, yeah, factorials are no longer restricted to integers. Pretty cool. Pretty cool. But then again, how does it stop? Factorials, they stop at 1, right? Now, in this case, like it said earlier, it wouldn't get. Where would it stop? Since factorial calculations stop at like 1 or whatever. Horribly inaccurate language. But we're just fucking around, aren't we? And yet I wonder, where would this point be for any non-integer? This is exactly the right question. ChatGPT glazes me up. How can you not kind of like it? But you shouldn't. But all right. The process stops because the integers are spaced 1 unit apart. After infinitely many subtractions of 1, you reach 1. But it doesn't reach 1, does it? Yes, exactly. That's what I'm saying. You've crossed 0, enter the negative numbers. So the recurrence never terminates. They choose a value that they already know and work toward it. The most important anchor point is the gamma of, I'm just going to call it gamma, right? Gamma of 1/2. So then we have, all right, what do we, yeah, square root of pi, right? Suppose you want to calculate the factorial of 2.5, and then you got, you add 1 to it, obviously, and then you get this, you get that, you get this. get that? Since, oh, and you can stop the function because you already know what that function is. Yeah, but you wouldn't have an anchor for pi, would you? For pi factorial, however, something different happens. Yeah, there's no, yeah, it's not an integer. Repeating the subtraction by 1 will never land exactly on half, so there's no finite chain that reaches a known special value. That's why pi factorial does not have a, dude, they're giving me this, but it's interesting. All right, so does not have a simple closed form. Instead, pi is simply the special function value. Now, this must have been done numerically. Could you prove it? Well, how could you prove it? It probably would repeat forever, just like it would be an irrational number, right? All right, so anyway, and then would you, huh? All right, first of all, this must have, this anchor point, and I'm going to put it in quotes because I hesitate to call it that, would have to be found numerically, right? Interestingly enough, no. No, I'm not saying 1/2, you goddamn asshole. I'm saying of pi. No, you dumbass. Not of 1/2, but... No, wait, what was the anchor point again? I think I mixed it up a little bit. Oh, actually, they probably said that an anchor point wouldn't exist for pi. Now, what did they do up here? Now, that was the other one. No, what I meant to say was, but for gamma of pi plus 1, there would be no known anchor function. They would just go through this, and then pi factorial would have to be calculated numerically, correct? Yes, and numerical methods are used. I just hate this fucking numerical shit. You with me? I wish everything could be computed numerically. Honestly, feels like cheating. I know that's naive, probably, but there's something in me that was like, oh, what if we could just... It kind of takes away from the power of... I mean, it's still logic, right? So it just doesn't feel very concrete, very precise. But I guess, reality. I mean, this is whatever. Shouldn't be precise. So extra credit compute pi factorial. But they want me to... So then, what answer would the book expect? And how would I do it? Possibility 1. The book expects pi factorial equals gamma pi plus 1. That can't be it. That's way too easy. But then I would have to use numerical methods. And then this one looks extremely similar to possibility 1. Possibility 3, the exercise comes after proving the gamma recurrence. Then the point may be to recognize that factorials can be defined for non-integers. Yeah. So this was kind of like, I was trying to break out of a steel trap here using my... Whatever, I'm not going to finish that analogy. All right, so essentially, I guess sometimes, and this is the reason I would say, but I was going to say this is the reason you shouldn't spend too much time on one given assignment, and still, I learned a lot. you should try to have some sort of cap. 30 minutes. And I mean, no, wait, you know what? We're going to say 20 minutes, but 20 minutes where you haven't tried anything for 20 minutes. Not total time being on the assignment, 20 minutes of having no clue where to go next, trying to figure it out, asking questions, but getting stumped all the way. And then you should have to recalibrate and try to figure out what is the question actually trying to teach me, because you might be latching onto something, like in this case, something that is not really the point at this level, right? You're not ready. I mean, you don't even, yeah, whatever. I'm speaking, oh my bad, whatever. All right, so this would be, all right, so we finished 18. Now the next one we're going to do is chapter 3.5, or section. Is this chapters? Let's call it chapter 3.5, counting subsets. See you later.